How y'all doing? Awesome. Awesome. If you could help me out real quick. I do this gig where I go around to conferences, and I go on these trips, and I talk to my boss about things, and I say, yeah, I'm going to Columbus, go to a conference at a movie theater. And he's like, sure. We're going to pay you for that? And I'm like, yeah, you are. So I need you all to smile and wave, at least all of you in this room. Sorry, everyone else in the other rooms, but if we could get this so we could show everybody that, hey, awesome. Thank you. That way we can, they can understand why I'm here and that I actually did work and talked to people. So I'm Scott McAllister. I'm a developer advocate at a place called ngrok. Anyone here heard of ngrok? Nice. All right. So the rest of you, you'll hear a little bit about ngrok today. What I'm going to do is I'm going to tell you about our journey that we took in creating an Ingress Controller. By taking you through that journey, I'm going to be telling you about our product. I'm going to be telling you about our company. I know I've been to a lot of software conferences. I've been in those seats, right? And you sit there and like, is this a sales pitch? I promise I'm not trying to sell you, but I am absolutely do need to tell you what we provide so you can understand the decisions we made and why we made them, the trade-offs that we were faced with and why we went with them. This is our story. Your situation might be a little different, but hopefully with the things that I'm sharing with you today, the lessons that we learned, that you can take the things that I'm talking about today and take them into your situations, whether it's to learn a little bit more about Kubernetes, a little bit more about Ingress or Ingress controllers, or if you want to learn a little bit more about ngrok, there's going to be a little bit of that too. But the hope is that you can become a little bit better from the things that I'm sharing today. So as I mentioned, we're going to talk a little bit about ngrok to get you on the same page, and then a little bit about the terminology in Kubernetes. And because I'll be honest, as you learn about Kubernetes and about that whole ecosystem, there's a lot of terminology and there's a lot of concepts that might be foreign, or as we learned today, there might be terms that mean one thing in Kubernetes and mean something completely different somewhere else in all of our other parts of development. So we'll be going over those just again to level set, and then we're going to talk about how those things come together, and we're going to see how those combine to make goodness. You're going to see a lot of trade-offs. I'm going to talk about trade-offs throughout the process that we made. A lot of the decisions that we made, as is the case in many of our software projects, they were selfish in the sense that we needed the whatever feature or whatever functionality for our own system, for our own processes, for our own architecture. But hey, it works for us. Why not also for our users as well? So think back to a time that you created a new project, a new application, a new service, and you loved this thing. It was so beautiful to you. It had this great functionality. It might have been green. It might have had things sticking out of it, but you loved it. No one could tell you that this thing was ugly. And you knew that once users got a hold of it, that they would also be as excited and want to use it as well. However, to get it out to the users, there was a distance, right? You had something running on your machine or maybe on a server that you had, and you needed to get it out to your users, to your customers. People would actually pay you money for your software so you can keep doing it, right? Because at the end of the day, we do need to pay bills. To get something out to the internet requires a few steps, right? You have to know about NAT and DNS and certificates for security. You have to know all these things to just get that one service out. Then if you build another service or build more functionality, you have to do all that stuff again. Or if you change your environment, you'll have to know other parts of networking to get those parts out to the internet. Each time you do that, you have to kind of be an expert in those areas. And that's where ngrok comes in. ngrok is a service that allows you to not have to worry about that connectivity. You connect to ngrok, ngrok connects you to the world. That's my sales pitch. That's it. Okay? It runs generally as a CLI. There's a CLI that, again, runs in your terminal. It's a process that you have a command. You say ngrok, you say the protocol, you give it a port, whatever port the application is running on your box or whatever box that ngrok is running on. And then you can specify a domain. That way you can tell ngrok, hey, I want this thing and I want to reach it at this domain. Ngrok then does the magic where it takes the port that's running on your machine and makes sure that it's accessible on the URL that's provided. And so then you have a URL that you can share with your friends or share with your customers and get access to what you're doing. The reasoning behind all of this came from the founder and the inventor of ngrok. And this is the thought that he had. The thing with developers is we're essentially still working with the assembly language of networking. All the other parts of our development lifecycle, we've abstracted out. In our front-end code, we're not using, well, okay, some of us aren't using vanilla JavaScript anymore. We're using React, we're using Angular, we're using Vue, or whatever new framework is of the day. In our back-end, we have frameworks. We have SDKs when we want to deal with APIs, right? Rather than building our own HTTP requests and parsing JSON, if I'm going to work with, say, the GitHub API, there's probably an SDK, or at least I'm going to look for that first. I'm going to look for that SDK because I want to deal with my native objects and abstract out that whole HTTP conversation. Have the library do that for me. Similar idea and similar concept with ngrok and networking. So going back to our little application, we love it, right? We have code that runs, it works great, it has dependencies, but people are starting to use it, and they're starting to use it more often. And so you need to expand, you need to scale, you need to add new features to this thing. And so what you can do is you're going to need to probably compartmentalize things a little bit. And to scale, you can use something called containers. With containers, it essentially allows you to encapsulate your application with the application code and your dependencies and have it essentially not care about the underlying operating system or underlying hardware. It's just going to be running inside of that container. So in theory, right, it can be the same on your development environment as it is in production, no matter where it's running. However, as your things get bigger and things expand, you start adding more and more services, you're going to need to communicate or orchestrate between the different containers. And that's where Kubernetes comes in. Kubernetes is an open source, what they say, container orchestration platform, I believe is how the official term is for it. Google developed it years ago, as we learned in our last talk, for a use case that they needed. Now, Google's use cases are on a scale that most of us aren't using, right? They have huge setups of infrastructure, and so they have goals that are this big, when we're maybe this big, but still, when our application is expanding and growing, we can jump into that same technology that they have here. So with Kubernetes, it uses those containers, however, it's kind of misleading because containers themselves aren't the things that run in Kubernetes. This begins our portion where we talk about terminology that's a little different. So in Kubernetes, the atomic unit of Kubernetes is called a pod. Now, if you're familiar with containers, some of the popular container runtimes are things like Docker and Containerd. But Docker, if you look at the logo, it's a whale. And so pods came from that terminology. Thinking of a group of containers would make up a pod, kind of like a whale pod. So in English, that makes a lot of sense. So with a pod in Kubernetes, you're able to essentially wrap your container inside that pod. It's identified as a pod. And then you essentially want to have a single container per pod, usually. For today, we're going to be talking about a one-to-one relationship between our containers and pods. You may get to a point where you're thinking about multiple containers in a pod, but that's beyond the scope of this talk. That's when you get into something called a service mesh. Not something we're going to be talking about today. However, it is nice, it is clean to keep a pod having a single task, right? And then as you scale your application, no matter if you put multiple containers in a pod or you use lots of pods with single containers in those pods, as you scale, you always want to scale by adding more pods, not by adding more containers to a pod. So in the spirit of abstraction, since we're talking about abstracting out things, we're going to abstract out the details of our pod for now, because our diagram is going to get a little bit bigger, because as our application is going to get a little bit bigger, we're going to start adding more pods to our application. And so we're going to take our application, we're going to add a couple more pods, but those pods need to be able to communicate with each other. They live inside of the cluster of Kubernetes, and they are essentially separated from the world, but they need to be able to talk. And that's done through something called a service. That's right, service. Generic name of service. Capital S service, because in the rest of our application life, our application, notice it started out as a service, which isn't the same thing as a Kubernetes service. It could have been named better. It reminds me of that joke, right? I think you've all heard it, but I'll say it again. The 3 hardest things in programming, right? Naming things and off by 1 errors. Exactly, you're welcome. So with that communication, services only handle the communication between the pods. As we see in our diagram here, the pods are living east-west. I did that to kind of illustrate the fact that that communication is called east-west communication. When people are talking about network traffic in Kubernetes and outside Kubernetes, they talk about going in between pods as east-west, and then outside of the cluster going into the world, that's north-south. So in our case, our east-west conversation is handled by the service, and then we configure Ingress to be able to connect to our users. Have that north-south traffic that allows the traffic from outside the cluster to get inside the cluster into those services so that we can provide that functionality to our users. Now, Ingress needs to be defined or used by an Ingress Controller. An Ingress Controller essentially sets the rules for Ingress for your application. An Ingress Controller there can be lots of controllers that make up a single Ingress, but essentially it allows for that Ingress to have settings for things like load balancing traffic, for setting up service or external URLs for the services to be reachable, and then allows for those containers allows for that communication to happen. Now, a single Ingress can have lots of controllers, or it can have one single controller. It depends on what your needs are. A common setup looks something like this, where we have our Kubernetes cluster here on the left, and we have our Ingress controller right there. We have an Nginx Ingress controller providing a proxy for that cluster, and then we have a load balancer on top of that. That load balancer, we can assume from this diagram, it's probably orange, well, it is orange, so it probably is what? Amazon? Right, Amazon. And so if we're running on Amazon, that load balancer works great. But if we take that application and we decide we want to move off of Amazon, then we have to have we have to pull out that load balancer and put in another one that runs with that whatever environment that we're running that cluster on. So let's talk a little bit about Ngrok's journey. Almost 10 years ago, I think roughly, our founder, Alan Shreve, he was an engineer at Twilio. And he was working with webhooks, and he needed a place for webhooks to go to basically give them a destination so that he could process his code and verify these webhooks and work with them. And he spun up this little project that exposed his local host, gave it a URL, and thought, oh, this is kind of nifty. And then he shared it with some friends, and shared it with some coworkers. And as we all do when we share something, people actually got excited, and we were excited that people got excited. And then he shared it with the community. People in the community wrapped around it. And folks who use it in the room, I'm guessing that's probably what you use it for. Some sort of development tool to expose your local host so that you can essentially have a URL that gets to your local host. Now, with that building up of that platform that Alan did, he added more and more to it, and then over the last few years, actually built out a company around it. And the team has been building out a platform that has been a lot more robust, but they, like every other startup, have come into that one age-old question, again, that Chris talked about in the last talk. It's a tough one, right? Go monolith or microservices? You go monolith, You have a lot less infrastructure complexity. Everything's in one spot. You know how to run it. It's fast. When you're trying to get something out into the market, speed is everything, right? You have to get things out there. And so it makes it a lot of sense. I shouldn't say a lot more, using my words carefully. It makes a lot of sense to go monolith. However, the thought of the day is microservices, microservices, microservices. And so with microservices, we keep things separated, compartmentalized, easy to develop on. You can have different languages and different platforms running on different services, doing different things. And so Alan was thinking about this. And back in 2015, actually, when he was contemplating all of this, he came up with an idea that he officially in his blog post called it Neo-Monolith, but that's no fun. He also called it Lego Monolith, and that's a lot more fun to talk about. And in my head, Legos make a lot more sense than Neo, whatever he was saying. And so in this idea, you see that purple box, it looks a lot like a monolith. That's because he has everything separated out into services on a single box. All those services have the same name, same ports, and then as he expands out to other boxes, it's the same setup. So it's a hybrid of having a monolith and a microservices in what he called a neo-monolith, or a hybrid, or a Lego monolith. You get the benefits of being a monolith with the speed of development, but then also the benefits of being microservices. And if you notice, when you're ready to go with a service-oriented architecture, you're already on the right path. Things are already separated out. You can piecemeal take out each service of that Lego monolith and start putting it in its own environment, putting it in its own service. When he started expanding and thinking of Kubernetes and thinking of containers, this was the idea, and so that path was super simple, or at least he had a jump start. So we have this platform, right? He was starting to put things into, it's to this point, it was multiple people. And so they started to put things into containers, into Kubernetes. But to get that stuff accessible, to create a connectivity to our services, we were looking at, well, we have this platform that provides connectivity. We want to use that platform. We want to dog food what we're using, what we're doing. And so we had an idea, and it kind of caught on. There were actually other users that used the same idea. And so notice before, from our simple diagram that we had of Kubernetes, this is not that simple diagram. This here is documented by a user from the community, where they essentially took ngrok, you had that CLI, right? They took the binary from that, made a container, put it in a pod, and gave it a service. And then with that, they took this service, remember, capital S, proper noun, service, and then they essentially ran the pod, expose an Nginx service that would expose everything else, but it would point to the ngrok service. I mean, it worked, right? But it was a little weird. Not quite a sidecar. One of the engineers at ngrok looked at my picture and said, well, it's not a sidecar. It's like, yeah, but this picture's great, so I'm going to keep this anyway. So, but it's not quite a sidecar. But others have done that, where they actually just run ngrok separately from Kubernetes, and then they just kind of point ngrok to the port that Kubernetes is exposing, and then expose that and whatever. However, in this case, we were sort of embedding a weird version of ngrok inside of Kubernetes. And then that weird version was like running in its own service. And then when we needed to make changes, we had to change the service. And would it work with everything else? We don't know. And when we were doing things like this, we had to think about, well, this isn't working with the rest of our setup. And if this isn't working, then if we have to keep adding things to this, it started turning out that that ngrok application that we were using for ourselves, we started making changes to it. And it wasn't working anymore because now it was totally different than what the rest of the world was using. And so it's like, okay, what's the point of doing this? If we want to provide connectivity to our own service, and we want the world to use us in the exact same way, maybe we should take a step back and think about some things. We want to make it so that our piece of software can run in a place where everybody is already doing their production code. So we had some decisions to make. We took a step back and thought, all right, let's build an Ingress controller that has an idiomatic API, which essentially means that it has interfaces on it and fields and values that people already expect, the things they already know. It's in a controller that is accessible inside of their Kubernetes manifests or their configuration files, but then also it's accessible by other controllers inside of their configurations. To seamlessly integrate is the key because there's pieces, as I mentioned with Ingress, there's lots of different controllers that you could have. We had that image before where we have the Ingress controller and then also the load balancer. You could have other things in there that are doing other pieces of your connectivity. All that gets pretty complex. So we want to be able to connect those things together. There's some changes we had to make to our application as a whole anyway. Because for us to provide this functionality, we needed to have things like load balancing. We needed to have encryption. We needed to have authentication for us, for our purposes. And remember, we started out as webhook verification and validation, so we needed to be able to provide that as well. So we needed to have all of these things inside our product first before we made the decision to actually include that into a Kubernetes Ingress controller. The next step was to look at the actual application and how we would get it embedded inside of a controller. Controllers are written in Go, which is what Kubernetes is also written in. And coincidentally enough, so is Ngrok. But it's running as a process outside of Go. So I mean, as we saw before, you had a CLI that was running in a separate process than your total application, and they talk to each other, but they're still two separate things. You spin up one, and it points to the other. But we thought, to make this a little bit easier for us, honestly, why not bring them together? Why not bring Ngrok, the functionality of Ngrok, as a separate application and make it a library inside of Go that can be used inside of a Go application? So instead of having a separate sidecar running to our Go application or to our controller, we'd have it embedded inside. So if you're familiar with Go, Go has a net.listener API, listen API. I get that word wrong every time. The net.listen API essentially spins up a web server for you. It spins that up so you can have a server that's running whatever application that you're running to expose it to the world, or at least expose it to your local host. Instead, we use the same interface and expose ngrok.listen, where you can set your URL, you can set your authentication, you can set IP restrictions if you want. But all of that is inside of the Go code in your Go application. Also, it makes it so that we can be a lot more dynamic with the tunnels that we're building. We can spin them up and spin them down with having to restart an agent. The agent is the CLI that we use. That's the name we call it. And so without having to spin up that agent and spin down that agent, we can do it dynamically inside the code. All things that needed to happen for an Ingress controller. So if you remember, this was the picture we showed before, where the common scenario is you have your cluster, you have your Nginx controller, and then you have your load balancer sitting on top of that. What we're able to accomplish is something a little different, where we have our users, they go through our controller, which goes through our platform, and then it goes into their cluster. They have the functionality that we needed, it's passed on to the user, and then able to use that all in one spot. However, you don't have to use all of that. That was one of the important pieces that I mentioned before. We wanted to be able to plug and play with all the other controllers. So if you're already used to using, say, Nginx for your proxying, you don't need to rip that out if you don't want to, but you can. As we developed our controller, there were a couple of things that we learned, some tools that we used that were helpful for us, that really got us going further down the path a lot quicker, gave you a really good start to what you're doing. The first is the runtime, or the controller runtime. This is the set of standard libraries that are maintained by the Kubernetes project. They use it themselves for all the different types of controllers that they build. And this gives you a great start to understanding how those APIs work together. And also KubeBuilder, which is a framework that runs on top of that runtime that allows you to give you that direction for building the application, plus gives you tools like good frameworks do, right? Gives you logging, gives you telemetry, allows you to essentially really get serious about development when you're building that Ingress controller. So if you're getting into that type of development, these are definitely tools that you'll want to get into. I'll have a slide at the end that shows links to their documentation. Now let's talk about some trade-offs. So Ingress controller is a standard today. However, in Kubernetes, there's a new thing coming along, and that's called the API gateway spec. With that, there's reasons why we didn't go with the gateway, or the gateway API spec. For starters, the Ingress controller, it's widely used. It's a widely used specification. Most of the community uses it. They're familiar with it. They understand that, oh, okay, here's an Ingress controller. I know how to set up an Ingress controller. I know what settings I need to put here. Ngrok should hopefully do that for me, or do that with me as I work with it. But more importantly, it's what we used internally. This is something that we were using, so we needed something that worked for us as well. If you look at the documentation for Gateway API, for the Gateway API spec, a lot of the implementations, a lot of the connectors that they have inside of that spec are actually still in alpha. There's a few that say beta, and HashiCorp's really flexing by saying that theirs is fully out and not either alpha or beta. I'm not actually sure where that one's at, but that was like one of the only ones, and there's this big list of folks that are working with the API spec, or the Gateway spec. There's a lot of specifications with it. They're still in flux a little bit. So that's why we made that decision. We made that decision to say, we're going to go with the thing that's standard. As one of the engineers said at Ngrok, he said, we wanted to walk before we ran. We wanted to use something we were already familiar with and then add to it. The thing about the Gateway spec is that the controller spec only supports HTTP or HTTPS. So the Gateway spec helps and supports the other protocols. And then also, it's the new thing going forward. It is the thing that we're going to be moving to at some point. But we wanted to start with what's established today and move on to what's going to be used in the future. And as one of the engineers put it, it's basically everything that Ingress is, just better. So there's always that going forward. So the current status, I'll admit, when I applied to speak at StirTrek back in, I think, what was it, January? We all have software timelines, right? We all work in software. We understand that we have goals, things we thought would happen. We thought that the Ingress controller would be out in production full today, and it's not. So we're still in beta. We are using it internally, though. We're using it on our infrastructure servers or infrastructure services, and doing it with our CI processes. And it's working pretty good for that. There's still some hardening we need to do for some edge cases, some security edge cases, to make it something that we would use with customer-facing type of scenarios. So we're still working with that. And we're also looking for feedback. If you're interested in working with an open source project, you can scan this, and I'll give you a free account at Ngrok, so you can play with it for 3 months. You're happy to do that. But that way we could use some feedback going forward. And honestly, the more people use software, the more that we find at least more bugs and things. Going forward, obviously we want to go GA. We want to release V1. And then after that, we're going to definitely dive into that Gateway API spec. It's the future. It's the thing that people are going to be using. And there are tools today that actually help make that migration a lot more easy. Here's some resources. just from the things I talked about today, controller runtime and kube builder, if you're interested in building, those are the documentation there. The documentation for our controllers in there, if you want to go look at that, see more details about how we're running things, how to set things up. And then some documentation on Ingress controllers in general, as well as the gateway API spec. Through the bright lights, I see a few phones up, so I'll give you a second.
The only question I have so far is if the slide deck will be available.
Yes, I can put the slide deck available. It'll be available on Twitter, which you can find me right there. So slides will be available. You can reach me if you have any questions. I'm available at the various sundry social media outlets. I believe those last two we added, what, in the last 6 months? Maybe 3 months? Anyway, the bottom one is definitely experimental. If you're inside it, neat. But yeah, reach out if you have any questions on there or we have questions here. I'll be sure to post the slides to each of those places so you can find them there. As mentioned, Scott McAllister, developer advocate at ngrok, and thanks for your time. Any questions now that I'm sliding out of the spotlight? Seriously, if you come down here and stand right here, can't see a thing. Like, I see like this group of people, and that's it. Yeah?
So, I was curious, are you familiar with like Bridge to Kubernetes used to be dev spaces?
Bridge to Kubernetes dev spaces? No.
Okay. So it's a service that worked almost as well as I wanted it to be. It used to be dev spaces that was bridged to Kubernetes, mostly for .NET. I was working at a .NET shop. But the problem that it was solving was, okay, you've got service A in your cluster and service B in your cluster, and you want to test a local version of it. You could tunnel a running local version of it so that service A could talk to it by using kind of like a newly generated subdomain of the service. So
Oh, cool.
So I can type something, send it to service A, and then it uses like route as headers so that it knows to route it to the local machine so that they can do local development against things in the cluster without mixing. And I was curious if there was anything with ngrok that had like similar things where I can create tunnels so that it can go through my normal like end-to-end testing, but hit my box at one point in that workflow.
Right. So yeah. So the question was, just repeating for the people in the other theaters. Essentially, you had a setup that allowed you to tunnel into your local when you were testing for your local environment, and tunnel from your Kubernetes services, which were running not locally, they were running up on a cloud somewhere. And does ngrok provide something that could help with that? Yeah, you could. It wouldn't be that. I don't believe it would be that Ingress controller. I believe you would be running the agent itself. And so you'd be running the agent itself like as a sidecar in the CLI. You'd point it at your local services. It would provide a URL. And then I think you can put that URL into that test, right, for essentially testing that service?
Yeah. It's like a subdomain of the service that you have. Because Kubernetes, I think, launches its own service in Ingress that you hit, and that's how it manages everything.
You're right.
But it allows you to just to your bespoke code. You can debug right on your machine as part of the workflow.
Right. I haven't heard of that specifically, but in my head, the mental model seems to work. So if that makes sense. Basically trying to say, I don't know for sure, but it sounds like it could work as, if you just need that subdomain, then ngrok, you can fire it up, set up at that subdomain, because you can have your own custom domains and subdomains when you're working with ngrok, and so it can provide that same connectivity. So, yeah.
First time I've heard of ngrok, but do you have like levels of support, like developer, like?
Totally. There's a free model that you can use that is.
And is there enterprise? I work for.
Yeah, absolutely. Yeah. I'm not in sales, so I don't have like pricing or anything like that. So, but yeah, if you go to ngrok.com and see that there, or if you go back to that, if you scan this, I was giving you permission to, if you scan that and sign up. Oh, geez. There we go. I can give you a professional license for 90 days. Yeah. I believe you'll have to sign up first and then give me that email address. Yeah. Yeah. Anything else? All right, let's eat. Thanks y'all for coming. Oh, and come take stickers if you want some.